All right, good morning, everyone, or good afternoon, depending on where you're coming in from. Thank you again for joining me today for my session on enriching Apex applications with semantics. Just a little bit of housekeeping. If you need to get my attention or my colleague Jason's attention, please feel free to use the chat window. If not, I'll proceed. So just a couple of quick introductions about myself. My name is Adrian. I've been working in the software development industry for more than 15 years. And over the last 5 to 6 years, I've almost exclusively worked with Apex. I joined INSOM late last year as a senior Apex developer. And I've been fairly active in the developer community. For the last 2 to 3 years, I've been a member on the OD-type marketing committee, and I've participated in several marketing initiatives and activities. Locally, I'm the founder and co-organizer of the Vancouver Apex Meetup Group, and also the current vice president of the BC Oracle Users Group. I do try to blog every now and then, but you'll mostly find me on Twitter. I try to do as much as I can to help contribute to the open source community. And most of my activities are actually found in the Oscar project. If you're not familiar with that, please contact me on Twitter and I'll introduce you to it. So as mentioned, I work for INSOM. Our company is heavily invested in Apex. We have been a long-time player in this space and today are probably the largest Apex consulting firm in North America. We have offices both in Canada and the United States, and are staffed with a good number of Oracle aces and even more brilliant minds. We provide a wide range of services to either help companies and organizations develop a solution with Apex or help them build in-house competency to do so themselves. We have a strong set of best practices and core values which we apply and impart when delivering solutions to our customers. Most of my career was actually spent on using information technology and computer science to help augment biomedical research. Like in many industries and domains, research is often constrained by time and money. And this is even more so for a software development project within a context of a biomedical study. As more often than not, these aren't a priority even though they are actually a critical part of the project. What I discovered 5 years ago was that Apex was extremely suitable as a software development platform for creating biomedical databases. Whether they use Apex or not, there are many biomedical databases out there. And unfortunately, scientific research actually works best when knowledge is shared. And a lot of these projects are in silos because they're highly specialized. And data integration is often a very painful exercise. So for the benefit of those of you who have not heard about the semantic web, I will provide you an overview of the technology and in the process help you to understand and figure out how this technology might actually be relevant to you and your Apex projects. Last but not least, if the demo got cooperative, we will look at how simple it is to make an Apex application semantically rich. And after which we will then close by examining some of the use cases where you're going to see that the technology is going to help you quite a bit. So the semantic web is also often referred to as the Web 3.0. Some of you might have heard about semantic elements in HTML5. These are elements that are very useful for describing content or defining how components are actually going to be laid out on the web page. So without explaining too much, anyone involved in web development or web design would naturally know what is meant by a header or footer. We all know that H1 means it is the first level heading for a division of text. And usually the text that's contained within the H1 text, they would have large fonts and maybe also be rendered in bold letters. There are also other elements like article section, and a site. These are perhaps lesser known, but they're extremely useful. So with this diagram, it actually allows you to appreciate how content can actually be compartmentalized and arranged such that they make very good sense. While I was researching materials for this presentation, I stumbled upon a very interesting cheat sheet that I thought was worthwhile sharing. It is from the website HTML5 Doctor, and it contains a workflow diagram to kind of help you in the decision-making process on when to use HTML5 semantic elements or when to simply rely on the ubiquitous div tags. Notice how this flowchart, which was originally designed for human consumption, could actually be used by a web crawler to figure out which component on a web page is actually worth indexing. That's it. While semantic HTML5 elements are, these are a very interesting topic to talk about. It won't be the focus of my session this morning. There is actually a slight difference between that and what we really know as the semantic web. So just a bit of history. Semantic web is not new. It's been with us for more than 15 years. I think like many great technologies that are out there, it takes many years to kind of mature. For example, if we looked at artificial intelligence and machine learning, these technologies have been around since the 1960s, but really only took the spotlight as we had this huge data deluge. Recognize this gentleman? This is Sir Tim Berners-Lee, and also known as the father of the internet. He is also credited for proposing the idea of a semantic web. In May 2001, he wrote this article about, it was entitled Get the Idea. And in that article, he had suggested that content on the web should be structured. And this would allow computers, not just humans, to process and understand the data that's published. And in doing so, you would allow machines to be able to access the data and understand it in context. And it could perhaps then allow many of our day-to-day mundane tasks to be outsourced to highly efficient software agents. Some of you might ponder and ask if this is necessarily a good thing. I think there's always a positive and negative side of any type of technology. But in this case, I actually think that the benefits do outweigh the negative use of structured data. So this is the the layer diagram of the many components that make up the semantic web architecture. Central to this, and some of which I'll talk about, is are related to serialization. So at the bottom you have URIs for identity, you have RDF XML for persistence, you have ontologies, which are basically like dictionaries, and they are serialized using a language called OWL, and OWL actually means Web Ontology Language. And you have RDFS, which actually stands for RDF Schema, and its primary use is to actually help. It's an ontology to define ontologies. Last but not least, one of the more commonly talked about technologies related to reasoning, and that's defined in the standard called Sparkle, which actually looks a lot like SQL. So to make the dream of a semantic web a reality, we need structured data. And for us, Apex developers, how can we present data in the applications we write so that specially crafted software agents could find, understand, and act on information presented? Before embarking on this journey to the future, let's take a look at some of the existing methods and protocols used for storing structured data. So first off, we'll look at the identities. And like in all relational databases, we assign primary keys often for the sole purpose of data retrieval. Similarly, a data resource on the web needs to be identified. For data that's on the internet, that is often in the form of URIs, or Uniform Resource Identifiers. And in the case of multilingual web addresses, is the internationalized resource identifiers. So a URI consists of the following. It has a scheme. So most of you would be familiar with things like HTTP, HTTPS, or even FTP. And then you have the optional authority part, which would usually have your user credentials for accessing the resource. The host component, which is of absolute importance, and whether or not to use a port. Last but not least, you have the path, the query, and the fragment. So a typical URI for my favorite beer could look like this. If any of you are interested, just Google Grenville Island, Cyprus. It's a nice tasting beer. URIs are very important, and we should go great lengths to design them. It is so important that Sir Tim Berners-Lee actually wrote an article in 1998. The link is actually here, which he described how URI should be designed for longevity. In short, he says that cool URIs don't change. People change them. And here are some of the key takeaways that I gathered from his article. So again, design URLs not to last just for days, weeks, or months, but design them to last for years. And doing so, we should avoid component names that change easily. You might be surprised, but in his article, Tim actually suggests that we avoid including the software mechanism that generates the content. So what that means is things like path names where you have CGI bin in the past, even for us, ORDS, Apex, and even extensions like .php or .html. And the whole rationale behind this is that if URIs were to survive for many years, then it has to be technology agnostic. Both you and I know how fast technology evolves. Not to say that Apex isn't forever, but there is just simply no guarantee that you would be delivering content using the same platform tomorrow. There is also a danger that sometimes we tend to over-organize when simple really is better. And this is especially true when we try to categorize data. For example, when perhaps we want to link to a document, and in that process, including within the URI path, the status of the document. Now that changes very frequently, so it fails as a candidate for a good URI. So some other considerations, and if you take the beer example, I could perhaps put it under a path called alcoholic beverage, or maybe a little bit more abstract beverage. But instead I chose a much broader and stable subject, which is product. And so you have to really think when you design the URI, what actually changes quickly, and then come to a compromise and define something that's stable for years to come. So entities on the semantic web are represented as triples, and that would include a subject, a predicate, and an object. I have here an example where person 1 is the subject, the predicate is the name, and the object is actually Harper Lee, which is a literal string. So the statement here would mean that person 1 has the name Harper Lee. Triples the entities can also be described by more than one statement or triples. Here we have book 1, which has the name To Kill a Mockingbird, and book 1 also has the ISBN number. And you can also reference other entities. So book 1 here references the author as person 1, and if you remember in the last slide, person 1 is Harper Lee. So if we were to summarize this in the human form, it's just simply saying that book 1 is entitled To Kill a Mockingbird. It's got an ISBN code 978-0446-310-789 and is authored by Harper Lee. There are also many ways to store and access triples. One of the most widely accepted standard is the Resource Description Framework, or RDF for short. Some of you might find this acronym familiar, as it was used many years ago when RSS feeds were fashionable. I believe it's still being used today, but back then RSS feeds were very popular for content syndication. You could publish a summary of your blog post as RSS feeds, and partners could then consume these feeds and render your post appropriately on their own websites or portals. So here are some examples of RDF formats that are being used. I'm going to actually delve into RDF XML, since most of us would be web developers. The others, well, they kind of say the same, but XML is probably something that we're most familiar with. So in RDF XML, the first thing you really need to do in your XML file is to reference for the root element, the RDFS schema. Alongside, you can have other namespaces, like here I have schema.org, and I also reference 4F. 4F means friend of a friend. This was something created by Dan Brickley in the year 2000 for describing people and their relationships. And in my opinion, I think it would have been the first incarnation of the distributed social graph had it been more widely accepted. To describe a book, I use schema.org, and I'm going to actually talk about schema.org a lot more later. We have the name property again, which is the title of the book, and then the ISBN code, and for the author, we reference another resource on the web. So that looks nice, but you might be asking at this point, how am I going to introduce these concepts into an Apex application? And the solution is actually to use semantic markup. One of the earliest specifications to help kind of build this semantic web was micro formats. It's closely associated with the vcard format. Vcard format is something that we used when transferring things like context between phones and mobile phones in the past, probably still being used today. But microformats was created early in the century and was one time it was advocated by search engine giants like Google and Yahoo. But unfortunately, its popularity was short-lived, although the specification actually still survives, and we're actually looking at a second version of the specifications right now. With microformats, you can add HTML markup to describe entities such as people, organizations, calendars, events, reviews, and a couple more. And long ago, I was pretty tempted to publish my own resume online using microformats, and this would actually give web crawlers, bots, the opportunity to extract clean and accurate data about my skills and experiences. And then might have perhaps lend me my next big assignment. But I did think about it, and sometimes polished personal data can be a double-edged sword, and so I decided not to do that. And instead, I kind of borrowed an example from Andrew here, who decided to do just that. He shared his resume online. What I did was to just take a snippet of his resume and modified it for microformats too. And if you look at it, it's really very simple. You have an enclosing div tag that has a class hResume, and that tells you that within this tag it's going to describe a resume. And then it has other classes which you can then refer to, and within these classes you have properties. And the data is actually just supplied within a tag. So it's that simple. And the other thing to note is that you could even use these classes for styling purposes, but that's entirely up to you. We also have RDFA. RDFA is another semantic markup that can easily integrate into an existing web page. Like microformats, it also allows you to mark up content with attributes that describe entities, very similar to microformats, things like people, places, events. It's got recipes and reviews as well. But unlike microformats, it actually allows you to specify a scope or a context. So what it really means is that you're not limited to describe only entities that the specification defines. So in this example, again, back to the book, I'm just including some of the attributes that's required for RDFA. So one of them is the vocabulary that I'm going to use, the type of entity that I'm describing, and the resource here is for you to give the ability for somebody else to kind of reference the entity. And like similar to microformats, you have things like a property here, and the property here is the name, and the data itself is actually enclosed by the HTML tags. And so that's the rest of it. I didn't use 4F like I did previously, and the reason being is that Google heavily utilizes schema.org a lot. They're one of the key sponsors and contributors to the vocabulary. So while 4F is a very robust and long-time specification, I believe you would agree that technology that's adopted by a large and influential organization is often favorable. So I'm going to do a demo, and I hope I'm still logged in. So this is a little Apex app that I did to kind of showcase this technology. But before that, I would actually like to talk about two tools that I'm going to use for the demo. So the first one is the Google Structured Data Testing tool. And it's a tool from Google to kind of help web developers figure out what Google, the search engine, is going to actually see in your data. And to use the tool, it's pretty simple. All you have to do is either supply a URL to the web resource that you're trying to analyze, or you can simply copy and paste your code here. The second tool is the OpenLink Structured Data Sniffer. OpenLink is a company that is a huge player in the semantic web space. They're in the business of building a database for RDF triple stores. But they also have a tool that it really works as a browser extension. It's available for Chrome, Firefox, and Opera. I think they have plans to do the same for Safari and Edge as well. But here in Chrome, you can see on the top right, there's a little doggy that lets you kind of sniff what's on this web page, and then you can see what it actually sees. So these are the tools that I'm actually going to use to analyze the pages that I've done. So in the demo, I've created 4 versions of the same product detail page. The first one is just simply plain old HTML, so no fancy stuff going behind it. And if I were to analyze it with the structured data testing tool, you will notice that well, Google's just not seeing any interesting entities enclosed in your web page. Likewise, the data sniffer is not able to see anything apart from stuff that's pertaining to the web page. So this is something that's already embedded from Apex, but they're not describing an entity. But let's look at RDFA. So this page has RDFA properties that have been embedded in the HTML. And when we examine this page using the structured data testing tool, you'll see that Google is able to pass out those properties and is able to know that there is a product being described. It's got a name tag. Here's the description. You can even tell, oh, there are quantities available, and that's the price for a bag. Using the data sniffer, it sees the same. So it recognizes that RDFA is embedded in the page. and it basically tells you the same set of information. So just to highlight that Google is not the only company that's kind of interested in semantic markup. Here, I have an example of a tool that's provided by Bing, and it analyzes the same information, and it actually sees the same set of information. An empty attribute item scope declares that this content here is part of the microdata, and it's got an item type. And here it's full URL to schema.org's description of book, and likewise it also has a link that so this identifier actually allows you to then again have an external entity linked to it. It looks very similar to RDFA if you have not made that comparison. And also I want to highlight that these technologies are actually not mutually exclusive. So you could very well have parallel implementations of RDFA and microdata on the same page. You could even have micro formats by just simply including a class. And here's how microdata is going to look like. It's going to be very similar to RDFA. I'll look at some other content like business shirt. So as you can see, it's again able to read the data without doing any scraping whatsoever. So there's no peculiarities to how the data is actually presented to the machine. And I'm going to show you how. So if we examine this region, the product information, I have in this page, this region, added a custom attribute. Let's check this out to make it a little bit easier to read. So this custom attribute would include the item scope, the item type, and an item ID. And then for the product name, which is a property, all you need to simply do is to add item prop equals to name. And for office, I actually embedded in the sub-region. So in this sub-region, again, is a different type of property. So that describes the offer. And inside it, it's actually got this, I actually had this reference to, again, another entity which kind of helps define what's in stock and out of stock. And you can actually see a lot of this on the schema.web page. So that's the schema.org page for product. And if we looked at office, there's actually an offer type. And in offer type, we can see that it enumerates over a couple of values. So item availability, and then you have in stock only. So these could be a form of ontology, and it then allows other sites to understand what's in store and what's out of stock, because we've all agreed on this standard that this is how it's being defined. So in order to translate that in my Apex app, all I simply had to do was to add a computation, and if I knew that the product was available, then I would render the appropriate reference, and that reference actually being used. when we when we display the availability. There you go. So the third one I want to go through, and it's probably the one that I get most excited about, it's JSON-LD. And JSON-LD really means JSON for linking data. Data in JSON-LD can be placed anywhere on the HTML page. They are enclosed in a script tag, and you just have to make sure that the type is actually application/LD plus JSON. And the reason for that is that it is very much JavaScript, so you have to tell the browser that this has to be treated as a block of data and not JavaScript. If not, you get lots of errors. Just a couple of things to point out is that if you see a name that starts with an @ sign, that actually means that this is part of the it's a keyword within the specification itself. So I'm just going to show this again on the demo. We'll pick women's skirts. So similarly, structured data tool is going to be able to see the same set of information. And the data sniffer is able to tell that it's JSON-LD, and again, it knows what's contained in this page. So I added a after footer process, which is really just a bunch of PL SQL code that would take the data and rewrite them as JSON, and then enclose them within the appropriate script tag. And if you looked at this page in the source, don't want this. You would actually see this data block that appears within the page. So it doesn't really matter where you put it. I used to put it up before the regions itself. It can be anywhere as long as it's enclosed within the script tag. And straight away, you have semantic data right out of your app. So with so many options that have been presented, you might be wondering which is better. And I have to say, the classic, it really depends. There are a couple of things. So I personally prefer using JSON-LD, as I feel I can keep the implementation separate from the HTML content. So from the demo that you've just seen, some of you might actually appreciate why this is so. With the JSON-LD, I could actually just decouple any support for semantic markup by just disabling that piece of code, and I'm done. Whereas in the case of microdata and RDFA, it actually means me going through every single property to try and take out those components. But that said, it does introduce a fair amount of data redundancy since I'm actually presenting the same data twice. There are workarounds that, but it would just add up the complexity. And the other consideration is that, as I said earlier, that you could be making use of RDFA and microdata for CSS styling purposes. And in the case of JSON-LD, that's just not going to be possible. So moving on, I just wanted to kind of briefly go through a few other what I consider semi-semantic web technologies, and one of them is the Facebook Open Graph protocol. Some of you might have heard of it and perhaps have used it. I know this is very commonly used in WordPress sites and Drupal websites. OGP was created by Facebook for the purpose of helping them define their social graph, and it does allow authors to present their content in a format that Facebook scrapers can pull important components of your web page and then render them appropriately on the social network itself. So here's one example of the OGP. It only requires you to have the basic 4 properties, which are the type, title, image, and URL. There are more, so please refer to their developer documentation if you wanted to know more about this. There are also Twitter cards. Twitter has 4 different card types. One of them, the summary card, which is perhaps the most used. Like OGP, it's got a couple of properties that are essential. Summary cards with large images is really an extension of summary cards. And what it really does is instead of just rendering a tweet in your post, it actually showcases a huge image, right, that you specify. And then there's app cards and player cards, which either lead you to Play Store or iTunes Store, or in the case of player cards, it opens up to write the media viewer. So here's an example of the Twitter card. And the reason why I kind of want to talk about this is that there are actually examples that I find that represent what Tim Berners-Lee was really looking for in his semantic web vision, where web pages, if they had contained structured data, machines are then able to understand. So in this case, you have Facebook and Twitter being the software agents, and they are able to read your web page, pull out the structured data, and render the content in a way that's suitable for their website. And all that without any humans involved. So I used an example from Rule's Apex Press Weekly. So if you were to share this link of his newsletter on Facebook, Facebook automatically then knows to present the image that you specified on the left here, the title on the top, bytes about from the description in the content area here, the source, and also the authorship. Likewise on Twitter, here's a single post. In the same post, it's got summary large image associated with it. So Twitter then knows to render a large image. In this case, it's actually the avatar for, I believe this was Nick, and then bits about the title and description. Next, I just want to cover a little bit about ontologies. I talked to Ben about he was an expert AI instructor, and after hearing what I said, he wasn't really impressed, and then he asked me this question. He said, "What do you find? Do you find meaning in a dictionary?" And I sat there stunned for a while and tried to worm my way out of this. And his response to me was that a dictionary is really just a book, which we as human beings, we socially define certain descriptions. So we give meaning to terms, and we then write them in books, where we persist them and share these definitions. So that's what ontologies really are. They encapsulate our knowledge into well-written and well-formatted dictionaries. So one of the most interesting projects that I came to learn and use previously was this project called Freebase. It really wanted to be the structured Wikipedia of the world. It relied heavily on the crowdsourcing. So people like you and I would go there and add data in a structured way. Some of it was through data extraction, which they obtained from Wikipedia. But the important is that they expose these data as APIs, and that allowed us developers to integrate, this knowledge base in our own application. So one of the ways they could showcase this was this Freebase Suggest widget, and it's a simple jQuery text-based plugin that allowed anyone to add text field on a web form. And it had a type ahead, which would not only give you a list of possibilities, but it would help the person who's entering the data know what this term was really about. So when you said Francis Ford, you're able to distinguish between Francis Ford Coppola or Francis Ford, and you know that these are film directors. Unfortunately, or fortunately for them, MetaWeb was bought by Google in 2010, and many of these tools and APIs are right now deprecated. And what Google really did was to integrate the free knowledge base into what is now known as the Google Knowledge Graph. So I spoke a lot about schema.org. Schema.org is a curated form of some of the more commonly used vocabularies, things that help define things like books and products, events, and stuff like that. It is community managed. They use a public repository on GitHub, and it's actually co-sponsored by Microsoft, Yahoo, and Yandex. So it's not just Google, it's all your major search engines that are involved. Google Knowledge Graph was probably part free-based, and probably the other part was what Google had already been harnessing and harvesting as they scrape all the web pages out there. When you search Google Knowledge Graph, and let's say you were to search the term Chicago, it's not just going to give you links to the website or the Wikipedia page. It's actually able to give you a lot more things like points of interest and sports teams. And all this is only really possible because within Google they're able to associate things like Navy Pier with Chicago, Chicago Bulls with Chicago, and that's what they do. And although we no longer have the free-based search widget, we now have this Google Knowledge Graph search widget, which you can actually implement and incorporate as part of your Apex app. And I'm just going to show you a little short demo for that. So let's look for Larry Ellison. And so you see that same effect where it's going back to the knowledge graph and pulling all the data and rendering it so that you can pick the right person. And then it would have an identifier which you could then link back to Google Knowledge Graph's page on Larry. So for more information, you can look at this web page. It's a fairly simple way to get this widget on your page. So last but not least, I'm going to talk about the biomedical research community. They have this NCBO, which is the National Center of Biomedical Ontology, which takes the responsibility of aggregating a whole bunch of controlled vocabularies that are related to healthcare research. And like Google, they have made a widget and API available. And I'm just going to show a quick demo about using their widget. So I'm going to search on terms using a dictionary called SNOMED CT, and I'm going to look for cardiac arrest. Okay, this is where the demo gods are failing me. There we go. So it's searching a whole bunch of terms that based on my spelling, and instead of me, entering and spelling cardiac arrest wrongly, it's going to help and guide me to the right term to use. So how does using ontologies actually help a web developer like you and me? I should say it's probably not going to help us, but it's going to help your data analyst colleagues a great deal. And the reason is, if you look at this workflow, it really represents what happens when people do data mining. And a lot of times, time spent on data preparation, when you have simple things like typographical errors and just an extra white space, it can cause chaos when you're trying to do data analysis. All of a sudden you have an outlier when really it shouldn't be an outlier. So that's where control vocabularies are very, very helpful. So I'm just going to quickly finish up by talking about, so why is this actually useful for anything? I like to talk about Best Buy. Best Buy is one of the early adopters of semantic web technologies. And if you look at the product page, you can actually tell, what's contained inside. If you look at Google, it is able to look at, it knows that there is a product called the Garmin Vivo Active. It's able to see that it's got a whole bunch of reviews written about it. And it's going to take all that information. And when somebody goes on to Google and search, Google is going to present this in a mobile device, for example. It's going to show you the image of the product, name, how it's doing in terms of rating, and it can even tell you where you're going to get this product and at what price. Now this is really useful, and if you were operating a e-commerce site, this is going to help drive people to your site. And we should also pay attention to the fact that nowadays Google is also paying attention to how they can quickly display device information on a device. So if you have bits of data that they can, then choose how it's going to be rendered, you're going to show up higher in terms of ranking. And that actually leads me to my second point, which is about implicit data integration. Just not too long ago, I was actually involved in a project where I was tasked to consume a REST API, which was really just a GET call to get data. And on that project, they had another vendor who was developing that piece. If you were to kind of sit back and think about it, what if the content developers had, on the onset, they already decided that they were going to put semantic markup in their content? Then there was really no need to build a whole API around that. And I'm going to show you why. So if you had attended Kscope, here's this URL to get a list of talks that were on Apex, right? And some people might actually want to take that content and put that into a spreadsheet so that we could, quickly decide which ones we're going to attend. But unfortunately, in the current Kscope site, you're not going to get any kind of content out there. You're not going to easily be able to pull that content out. So you have to write scrapers, and if that format changes, you kind of hoop. But here I have a bunch of simple code. There's actually a library to extract semantic markup. So in the first example, when I first run it against the Kscope site, it's not going to be able to see anything. And I have I'm going to minimize this a little bit. I have a similar page here, which has that markup. I've got RGFA implemented in this. And what I'm going to do is I'm going to then try and extract stuff from this page instead. So you have all that content available to you in a structured way, and it's then not too difficult a task to translate this into a spreadsheet or even render it on a different page. And the final point about having semantic web, and particularly when we talk about ontologies, is that we have to really make sure that when we present data, they are of high quality so that other people could make use of them. My experience, that happened, the issues with dirty data happening in biomedical research data, causing high costs in terms of time and money spent on cleaning the data is just could have been saved. So that's about it. There's just a couple of take-home messages from me. First one being is, again, design your data to be shared from ground up, not on hindsight, but you can just quickly add markup and you're good to go. And I've spent so little time on code, and that tells you that adding structured data is really very simple when it comes to Apex. And again, use community accepted control vocabularies and avoid inventing your own. So with that, I'd like to thank you again for being here today. I do apologize. I think I might have cut in and out during the session, and that's because I'm using a wireless headset that seemed to have decided to sleep every now and then. I do apologize. So if there are any questions. So I have one question here which says, showed a bunch of solutions. So if I'm an Apex developer and want to make data semantically available crawlers, this is my recommended way to go. Again, there are many approaches to doing this, and my preference is still using JSON-LD, and that's because I think from a coding standpoint, it's a lot easier and less tedious, and the fact that it's decoupled from the presentation layer itself, I think that really helps. Someone asked if you could email questions. For sure, just direct them. Actually, if you can tweet to me, or Jason, do you have any email address that they could use to email questions? Okay, you can email me, and I'm just thinking how I'm gonna. So you can reach out to me by email, and that's my email address. So there is another question about whether classes are fixed. I'm guessing that the classes that you're referring to is the micro formats. They are fixed, and I think that's one of the limitations about micro formats. They're basically what you can describe is really dependent on the specifications itself. Whereas in the case of microdata and RDFA and JSON-LD, all you really have to do is to tag on additional schemas, and you can describe basically anything that you want. So could we get the Apex project with the search built in and instructions on how to integrate? I would like to share the demo app that I have, and I'm going to make that available to you as soon as I can figure out the best way to share it with you, such that I don't have to give you my Google API key. So I probably didn't talk about this, but in order to do this widget, you do need to get a developer account with Google and to get an API key. So I'll quickly remove that and let you be able to supply that, and you can have this application for sure. So Oh yes, and regarding instructions, the slides are available online. I just need to, I made a couple of changes and I'm going to make sure that it's updated and refreshed. So we are at the end of the hour. If there aren't any other questions, I'd like to again thank you for being here. Again, my apologies for cutting in and out. If you have any further questions, feel free to reach out to me either on Twitter or through email. And yep, I hope to see you around.